A considerable effort goes into understanding the biology and dynamics of infections, immunity, and disease. This is true for a given person and for the overall population. A parallel effort goes into understanding how to control existing infectious agents. This video introduces control, which will be detailed in other videos. To start, control efforts appear in two broad forms: prevention and treatment. Prevention and treatment efforts can happen at both the individual and population level. We'll start at the individual level. Prevention efforts fall into two categories: efforts to avoid contracting infectious agents and efforts to avoid further spread of an agent. Effective prevention depends on a strong understanding of the transmission dynamics of a particular infectious agent. For example, people get malaria from mosquito bites. To prevent malaria, people need to engage in actions that reduce mosquito bites, such as sleeping under nets or using bug sprays. If the infectious agent is spread through a different means, such as fecal-oral transmission, then hygiene and sanitation are important. Hand washing, for example, is useful for preventing E. coli and norovirus. Treatment efforts can have many different goals: to help the infected person to feel better, to cure the infection, and to reduce the infection's ability to spread. In reality, we often do not have the treatments that can achieve all three of these goals simultaneously. For example, some infections cannot be cured. In other situations, some treatments that are used to cure infections have uncomfortable side effects. Let's turn our attention to the population efforts now. At the population level, we can build structures, we can plan communities, and we can put policies into place to facilitate prevention efforts. For example, a community can decide to invest in building public bathrooms, stocking them with cleaning supplies, sanitizing them regularly, and promoting hygiene behaviors. We can also invest in the surveillance of disease patterns and transmission dynamics, and the sciences needed to understand them. We can also invest in sciences of behavior change, so we can facilitate the public's engagement in prevention and treatment. Even with good science behind prevention and treatment recommendations, implementing them can be challenging. For example, sometimes science leads to surprising recommendations, such as asking medical professionals to intentionally infect a patient in order to prevent disease. This recommendation is the backbone of vaccination. When science leads to recommendations that are not well understood by a community, are not in existing policies, or are not supported within current resource plans, it can be very challenging to control an infection. Some recommendations may not be popular because they challenge personal freedoms, like travel restrictions, or population resources. They are just too expensive to do. For these reasons, successful control efforts are interdisciplinary. They depend on biology, pathology, social science, and epidemiology at minimum to do them well. We need not only experts in completely different areas, but experts working together to collaborate towards a goal. In emerging epidemics, sometimes these teams have very little time to come up with some answers. The good news is that we're in an exciting time in which interdisciplinary teams focused on controlling infectious diseases are coming together on a regular basis to think through how to respond to serious health challenges. This MOOC is a perfect example. In the videos to come, we provide more details about what to consider in control efforts and how to respond.